Welcome back. So while you were gone, in between the last video and this one, I've kind of tidied up this data dictionary here, so it looks a bit better now. And don't worry, you'll have a copy of this in the resources section, so you're not going to be missing out on anything. But just where we left off, we talked about features, which is step 4 in the machine learning pipeline that we're using, or the machine learning modeling pipeline that we're using. And this is where you'll get different information about each of the features in your data. You can do this by doing your own by doing your own research, such as looking at the links above. That's what I did here to kind of tidy this up. Reading between this information here, so attribute information, as well as UCI dataset webpage. If you go through here are all 76 attributes, but realistically we only used 14, so only 14 attributes used, and that's what this data dictionary is. So basically a data dictionary just tells you about the data that you're working on. Wonderful. And so now, where are we up to? If we check back, we've worked through 1, 2, 3, 4, but have we really? So we've just kind of done it in thought. So now it's time to apply the tools that we've been going through to this section, right? So this data analysis section. So let's do that. Let's get our tools ready. So we'll create a heading here, preparing the tools. We're going to use pandas, matplotlib, and numpy for data analysis and manipulation. Wonderful. And so at the start of every notebook, what you might do is import, this is what you'll probably see out in the wild, is a big chunk or one big Jupyter cell importing all different tools at once. You don't necessarily have to do it this way, but it's kind of industry standard to do it this way. So let's see what that would look like. Import all the tools we need. So what we might do is make little subheadings here. So that way when we're working through this step-by-step process, we've got all the tools that we need. And now, again, a project might not start out like this. I'm only doing it this way because this is what you'll see with the sort of finished project. What you'll more regularly do is kind of how we've been working with it in the past, is just import a tool as you need it. So when you see this big block of code that I'm about to type with all the imports and all different tools and whatnot, you might look at it and go, holy goodness, I'm not sure what's going on with everything there. But that's okay. What you'll do is, because you've got the framework now, you've got this, and we've seen different ways that we can apply different tooling, you'll be pretty familiar with all of the functionality that we're going through here. And if not, that's perfectly okay. You know where to look and you know where to get help. So let's do this. We'll go regular, EDA, and plotting libraries. Here's where we're going to import NumPy. EDA stands for Exploratory Data Analysis, by the way. Got to learn not to talk in acronyms. We coders like to shorten everything. So import NumPy as NP, import pandas as PD, import matplotlib.pyplot as PLT at PLT. Come on, Daniel. Import Seaborn as SNS. So Seaborn, remember, is just that plotting library built on top of matplotlib. Matplotlib is the base plotting library that we're going to be using. So I'm going to do matplotlib inline because we want our plots to appear inside the notebook. So this is what this little magic function does with that percentage sign there. And then we want to import models from sklearn or scikit-learn, also known as sklearn. You're about to see that in a second. So from sklearn, we want a linear model, import logistic regression. Now, if you're wondering where these models came from, remember we've got scikit-learn model map, choosing the right estimator. Wonderful. So we followed this along in a previous section. We're working on a classification problem, so we're only going to be importing classification models. So from sklearn.neighbors, we're also going to import another model here. So k-neighbors classifier. And you'll remember this one. ensemble. You might not have seen the first two, but that's okay. We'll talk about them when it comes to it. Random forest classifier, we have seen that one. And then we're going to go model evaluations. We're going to go from sklearn.model selection, import train test split. This is going to help us split our data into training and test sets. We'll also import cross-val score from here. Now, if you're wondering how I know all these, it's because I've had some practice. And if you're looking at this going, holy goodness, there's a lot of things to remember to import. And you're like, oh, that's what I'm saying. I'm agreeing with you. But machine learning is a very broad field, and there's a lot of different ways to do similar things. But after some hands-on practice, like what we're going through now, you'll start to get a bit more familiar. And again, it's no rush. I still have to look up things. So I've done these on separate lines, these two. I could have done them on the same line because they're from the same module, but just to keep it a little bit tidy, a little bit Pythonic, we want to go here from sklearn.metrics, import confusion matrix classification report. Well, they may be familiar from the evaluation section of the scikit-learn section. We go here, import. We want to get precision score because we're thinking in our head, this is a classification problem. What metrics can we use to evaluate classification models? F1 score from sklearn.metrics, import plot ROC curve, because we want a ROC curve. Whoa. You might be looking at that going, Daniel, that is a lot of stuff. And it is. This is 21 lines of imports minus a few comments. But this is the tools that we're going to need. So if we come back here, we may still even need more. I might have missed some. But this is kind of what you'll see at the start of a notebook, is because once we've set it up, we want to approach these and we want to minimize our time between experiments. So that's why we're getting all our tooling ready right at the top so that we can get hands-on as soon as possible. So we've got pandas, we've got matplotlib, we've got NumPy, we're working within a Jupyter notebook in our Conda environment. We've got scikit-learn, and now we're going to work through the data analysis section. So that means basically importing the data, having a look at it, and trying to become ourselves a subject matter expert, which is just someone who knows about the data, like a fancy word for someone who knows about the data. That's what we're trying to do in these 3 steps here. So without further ado, let's hit Shift and Enter, import our tools. Fingers crossed. If we've set up our environment to work, these should all import correctly. What are we getting here? Something wrong. Runtime error. MP ufunc size change. May indicate binary incompatibility. Expected 192 from cheader, got 216 from PyObject. I've actually never seen that error before. So this is what you come across, right? These type of things, even after you've had some experience, you'll come across these things. This warning. So we're just waiting on to make sure that this cell runs fully. It's already given us a warning. Oh, we're getting another warning. Here we go, mp.ufunc. Now we might let this cell run out, as in finish, because it's going to take a little while. Unrecognized arguments. Maybe I can't put this. This needs to go above here. There we go. Will this import? Yes, it should, and now we're getting no warnings. That's interesting. Well, that's the surprises that you'll get from day-to-day running, working with different machine learning code and different code in general, is sometimes it does things that you don't really expect. And so that warning has gone away. If it does come back in the future, we'll probably deal with it then. But for now, we'll assume that we've got our tools ready. Now we can start applying them.